Okay, so today we're going to start this lab off and notes off with a quick demonstration. This isn't going to take very long. This is going to be just a demonstration of the difference between high kinetic energy, high temperature fluids, and how they interact with some fluid coloring that I put in them, and also low temperature, low kinetic energy fluids. And this is a demonstration of a couple of things that I'll talk about as we go. So first off, I'm going to show you right up front. This is a large beaker with water in it. And the water in it has been heated and it's sitting on a hot plate. Okay, this water is at room temperature and it's just sitting in this beaker on the table. Okay, so this is room temperature water. This is heated water on this hot plate. This water, since it's heated, has high kinetic energy. Okay, this water, since it's not heated, has on average low kinetic energy. Okay, so what I'm going to do is add I'll try 3 drops or 4 drops of food coloring, red food coloring to each of these mixtures, or to each of the beakers full of water, and we're going to watch what happens. Okay, and I'm just going to see. I want to make sure I get enough here to make this obvious. 1, 2, 3, 4. I think 4 is good enough. We'll go 4, and then here's the second one. 1, 2, 3, 4. So I added 4 drops of food coloring. You can kind of see, first off, so let's take a look at the one that's heated first. Okay, you can see the drops sort of fell to the bottom, so the food coloring is actually heavier than the water. It falls to the bottom. On the bottom, we've got a hot plate. Okay, so there's conduction of heat between the hot plate and the beaker. Okay, and so that's conduction. Okay, right? Within the beaker itself, the hot water the water that's heated by the beaker below rises to the top, and then when it gets to the top, it cools in contact with the atmosphere and falls back down. That's convection, okay? So there's convection going on inside this beaker. Also, what else is going on in this beaker is that we have, since this is high temperature, it's also high kinetic energy. So all these water molecules are doing that water molecule dance, right? And so as they do that dance, what you notice here is that the food coloring is dispersed kind of uniformly throughout the beaker. There's still some at the bottom, but you can see that, the whole thing is kind of a pinky color, right, of red, and you can see that it's still dispersing in the bottom right now, even as we talk, right? Now, if we look at this other beaker, you notice that the food coloring fell right to the bottom. It's not really dispersed hardly at all, and the water is still clear. Okay, you can see the water is still clear except for a few little droplets, okay? So in this one, this has low kinetic energy. Okay, there's very little mixing going on. There's no convection going on inside the beaker, no convection. It has low kinetic energy. So you can see all the, the food coloring tends to just clump together and not disperse at the bottom. Okay, and here it's dispersed a lot inside the beaker. So hot water, high kinetic energy, high average kinetic energy. Cold water, low average kinetic energy, low temperature. High temperature, okay? There's convection going on within the beaker because we have a hot plate underneath and cooler atmosphere on the top. And we also have conduction going on between the hot plate and the beaker. Okay, good enough.